So let's take up one of the conservative force, that is your gravitational force, which is also a conservative force. Is a subclassification of that. So let's recap the gravitational potential energy and the gravitational energy and gravitational forces from your previous grade. So what we have here is a 2000 kg elevator that is lifted from the ground to the 5th floor. So we have from the ground, so it moves to the 5th floor, right? This is the ground, and this has moved to 50th floor. Okay, and each height of each floor is 3 meters. Determine the increase in potential energy. How do you find that? So I hope you guys remember potential energy is given by m into g into h, where m is your mass, g is your acceleration due to Earth's gravity in this case, right? Due to Earth's gravity, g stands for that only actually. And h is the height. Now, if it had from the ground, it had reached to 1st floor, it would have been 1 into 3. But since we have reached 50th floor, it will be 3 into 50, the height that is. So in this case, this is to recap. Again, we are trying to recap things over here. So in this case, h is equal to 50 into, I don't know why am I doing this, 150 meters. I mean, I know you guys know that. So the potential energy that the system has, the object has gained is 2000. I'm considering g as 10 and h as 150. And this, whatever this answer is, so many joules. Okay, so one floor is into 3, second floor is into 2. Yeah, should have gained 6 meters high. Okay, now what I wanted to recall, one more thing, that is your derivation of mgh. So gravitational potential energy, let me just put that across as well. So it is the energy stored because of an object being at a particular place in the presence of a gravitational field, right? So that is your gravitational potential energy, and it's given by mgh. How do you derive this? If you guys remember, we started with work is equal to force into displacement, right? And we move an object infinitesimally slow, so against the force of gravity. So this force, our force, will also be almost equal to mg in terms of magnitude. But in terms of direction, if this is minus mg, this will be plus mg. So this is very slow, infinitesimally slow, or very slow, actually infinitesimally slow movement. So we're looking at that. So F will be equal to mg and our displacement will be equal to the height. And so as per your work energy theorem, it will be mgh as per work energy theorem. So all these derivations are done in your previous grades, but if you guys wanted a very slow version of the same discussion, it's there. You just have to search a bit. Okay, so we are looking at one of the conservative force, and that is your gravitational potential gravitational force. Actually, that's the heading, gravitational force.